Good day. We will now move forward to experiment 5, where we understand open channel flow using weirs. This experiment includes an open channel distribution and measuring device alongside with 4 types of weir accessories and a ruler to measure height. Our objective includes understanding what an open channel system is and how weirs attached to it would place and affect the system. We are to understand how flow rate conservation happens even when weirs are applied. The experiment consists of simple tasks by using different weirs with 3 specific LDL types of flow rate. Initially, all weir accessories need to be measured by their dimensions for later computations. We would then gather what would be the initial height before the weir, the upstream height above the crest, and the height after the drop. Here we are having a short group discussion for every member to know how the apparatus works and how the experiment concept works also. After all preparations, we are now start by using the rectangular weir with Q values of 500, 1000, and 1500. These flow rate values would remain constant in all weirs, and the goal here is to compute for the coefficient of discharge in every Q and in every weir. We can see here that one of my group members are trying to get the height difference of the water after and before the drop using the steel ruler as we call it. After successfully repeating the process 3 times for each Q values, we now turn off the machine and let the water drain. After it settled, we now introduce the new contracted rectangular weir and repeat the process. As you can see, we just simply remove the initial weir and then apply the another rectangular weir. All the weirs are attached to a specific place near the middle of the apparatus. The reason for the color purple water is because we integrated a dye in the tank so that we can easily observe the flow of the water. The marble bags are believed to be used for minimizing the abrupt and wild waves produced by the apparatus when we introduce high flow rate. After 2 types of rectangular, we now go to the triangular weir with the same Q values. One of the problems that our group encountered would be that the discharge of water after the drop is super slow, that the water becomes stagnant as time goes by. So as soon as the water drop, minimeasure na agad namin yung height kasi nandun yung peak ng flow rate niya and dun yung pinakatamang height na nakukuha namin. Basically, kapag tinagalan namin yung pagkuha ng height is nakikita naman sa video na natatambak yung tubig. This is also one of the main reasons that we use the 500, 1000, and 1500 values of flow rate, because exceeding more would result to a faster flow rate and then more stagnant water na. After conducting and completing the table, we now go to the last trapezoidal weir and with the same values of Q. Trapezoidal weir is the last weir that we are trying to conduct, and after this we would then get the coefficient discharge by using the Revox formula. The coefficient of discharge is the ratio between the actual and the theoretical value ng flow rate. No? It measures the proficiency ng ating flow or the proficiency mismo ng ating apparatus. On the other hand, the flow rate conservation can be observed also in an open channel. We can observe how the flow adapts when a high area consists of low velocity, and then after the drop, it will go to a lower area but higher velocity. No? And with that, our experiment ends. No? After tabulating all the data, we now proceed to the calculations.